Hello there, welcome to a drive-by code session. This time we're going to talk about how to build a parser using Nearley.js. We'll talk about the different concepts dealing with building a parser. So a grammar, what does it mean? What is a grammar in the context of building a parser, and also practically speaking, how to use the Nearly grammar generator, or not grammar, parser generator tool to do that. So we're going to be using JSON as the example. We'll build a JSON parser, basically probably not the whole thing due to I want to keep the videos kind of short, but we'll build part of it and perhaps leave the remaining pieces, the undone parts, as a homework assignment for you. Okay, let's get started. And as usual, Whitekit did these coding sessions beforehand, and I'm going to be replaying what he did and explaining them. So let's get into it. So the first thing he does is npm init-y, which is a handy for you all to know, to get the project started. That generates a package.json file. Whoops, I typed in the wrong place. Okay, so the next thing he does is install the Nearly parser generator tool. And I guess the reason it's called a parser generator, or I call it a parser generator, is because it allows you to write a grammar in the Nearly prescribed syntax, and it'll generate a parser for you. So you don't actually have to write the parser. I'll show you how that works. So now you can see Nearly is one of the dependencies in this project now. And the next thing we'll do, we'll just start writing this file, which has the NE suffix, which stands for Nearly, and this is a grammar file. So what we are writing here is a grammar. And in computer science, you might hear the term grammar associated with something called the CFG, which stands for context-free grammar. So when we're talking about grammars, we're usually talking about context-free grammars, which is a subset of grammars that are easier to make parsers for. So we'll be using Nearly to do that. Writing a grammar is relatively straightforward. I hope you will find that to be true. And Nearly will take that grammar that you write and generate a working parser in JavaScript for you. So let's look at what the first version of this grammar is going to look like. So this is the first version of this grammar. And this guy here we've written is called a production rule. So production rule. The production rule is defining a symbol. The symbol is called digit. So this defines what the digit symbol means in this language. And it's saying a digit is defined to be a 0. I'll call this arrow here, I'm gonna say that means so this means defined to be, and then these vertical bars, this just means OR. So there's an operator. So a digit could be any one of those things. Let's move on. So now this is actually good enough as a grammar. It's not very useful. It just matches one single digit. But let me show you how you compile a grammar into a JavaScript file. And that's how. So you use the Nearly C tool, which stands for Nearly compiler. C stands for compiler. It compiles this JSON.NE file and it outputs a JSON.js file. You can look into this JSON.js file. It's actually just a JavaScript representation of this grammar here written in this format. And in order to execute this or utilize this parser though, you need to kind of bootstrap a little parser script, and which I'll do here. So this is a template code or example code taken straight from the Nearly Getting Started docs. So YKit copy that, and then he's gonna tweak a couple of things. This needs to be referencing the JSON.js that was just generated. And then when we feed it something, we want to feed it to something that this grammar can parse, or this parser generated by the grammar can parse. He's gonna put this parsing inside of a try catch so that it outputs the error message more cleanly. Okay, so in order to run this, it takes the string that is fed into the parser, which the parser was created, or a new instance of this parser is created using this syntax here. And then we feed a string into the parser. And the output of the parser is a bunch of results, which it can potentially have multiple results in the case of ambiguous grammars. We're not gonna worry about that too much at this point. So, and in this case, there is only one result, and that result is an array with a string 1 inside of it. This guy inside the array that will end up, or that's the result of the parse. This is the result of the parse, and is often called the AST, or abstract syntax tree. But for now, we're gonna not worry about that aspect either, and just more concentrate on building the grammar. All right, let's keep going. So now if we feed a string into the parser, which it doesn't understand, which ABC is an example of that, it'll tell you that the character A is unexpected. Instead, I was expecting to see one of the following, either a 0, a 1, or 2, all the way up until 9, based on this rule, the digit rule. That's the only rule that we have, and it's expecting one of these characters, basically. So it doesn't recognize an A because it's not anywhere, A character is not defined to be matchable anywhere within this grammar, and therefore it causes a syntax error. All right, let's keep going. Now we should be able to match multiple digits. So, and at the moment, it would not do that because this grammar only matches a single digit. So we're gonna make it match multiple digits by using recursion. So this rule is called, with this rule, we're gonna define the symbol digits. And we're saying a digit can either be one single digit, or it could be one single digit followed by more digits, which can in turn be a digit. So, and this works by recursion. So let's say you had just one single digit. Well, that can be matched as a single digit. So one basically gets resolved as a single digit, but a single digit can be resolved as multiple digits, and therefore a 1 can be resolved as multiple digits. Well, what about the string 1, 2? Well, the string 1 again is going to resolve to a digit. The character 2 also gets resolved as a digit. Now how does this get resolved as digits? Well, this guy here, this 1 digit will get resolved as digits. And then based on the second rule, 1 digit followed by another digit. So these two together, let me use a different color here. These two guys together also becomes just a single digits, or single digits. That sounds really funny, but yeah, the combination of 1 digit and some more digits, it is digits. So that's how the character 1, 2, and if you can imagine if you add more characters here, like 3. Well, let me actually add another one in front of it, like here. If it were you had more digit, another digit, that becomes another digit, which can get combined with this digits, and you still have digits. So that's how recursion works with grammars, and this is what we're utilizing to match any number of a sequence of characters. So okay, so we updated this grammar to try to match multiple digits, and now, whoops, I typed in this terminal again, didn't mean to do it. And now I'm gonna say in Nearly, Nearly always takes the topmost rule, or the symbol associated with the topmost rule, as the thing to start matching the input on. We're gonna make that explicit by saying, hey, the input, and this input, I guess we chose to name it input. We could have named it anything we wanted. Some people like to call this start. We're gonna call this input. Okay, sorry about that. So we're saying the input consists of a bunch of digits, basically. And now that we've modified the grammar, we're going to rerun the nearly C command, but this time we're gonna put it in the scripts section of the package.json file to make that more convenient to run. We're gonna call this command gen parser. So now, this time we're gonna run npm run gen parser. Yeah, so npm run gen parser. Sorry, the output got a little messed up, but let me actually run it for you here. npm run gen parser. So to show it how it actually looks, so that's what it runs when you run npm run gen parser. Switch back to replay terminal, and now you can run the parse script again, so it's able to match multiple digits. Okay, so that's multiple digits. We'll put some put a more emphatic output, saying the parse was successful versus the parse failed. Okay. Again, if you give it input that it doesn't understand, ABC, it still doesn't understand it. It will give you an error message. All right, let's keep going. Okay. What about decimal points? Well, let's make it match decimal points. We'll say a number can be some digits followed by a dot and then some more digits. But it could also just be some digits if that number happens to not be a number with a decimal point. So this should allow us to match numbers with decimal points in it. So let's see that. Oh, one sec. So at this point, so we have a number, and we should be able to match numbers with decimal points. I'm gonna try that actually. So gen the parser, and then so yeah, so now the parse is successful given a decimal number. Now there's a shortcut in Nearly that we can utilize, which is called the character class. Which works just like the character classes in regular expressions, if you know those. So if you have a set of different characters that you want to match, you can use a character set, or character class, I should say, to represent that. And that looks like this. So this guy, again, is a character class. And again, it looks just like the character classes in regular expressions. So if you already know that from regular expressions, good for you. And now the grammar looks a lot shorter, more succinct, and it works the same way. So switch back to the replay terminal, and I think he's gonna test it out. So yeah, this is WhiteKit. Back to WhiteKit. WhiteKit does a gen parser and he parses. So now this parse is successful for the 12. It should, okay, it still fails with ABC. There's another trick you can use in Nearly, which is the plus sign, which I think it's in the something called the. This is a syntax that also works in regular expressions, but is actually a syntax stolen from something called EBNF. And this plus sign means one or more occurrences of whatever that is. And you need this colon here to activate this plus sign. So this is saying digits is one or more digits, and that you can think of that as the shorthand for that recursion, for this recursion trick that we use. Instead of doing that, you could just do that, and you run this, and it should work as before. Let me see. Yeah, and it actually internally Nearly has generated an extra rule for you. You can actually see it. So these two rules were generated internally by Nearly based on this plus symbol here, to support this plus symbol works, which essentially does the recursion trick that we did manually in the previous step. I kind of don't like the display output of this symbol. This symbol looks a little gnarly. So maybe like switching back to the more explicit form is nicer in terms of the error output. Okay, so now we got numbers working. What's another thing we need to get working? So we got numbers. Let's get booleans working. So how do you get booleans work? Let's define boolean. So a boolean can either be the string literal true or the string literal false. And so if we run the parser again, we'll see that the parser is able to parse the word true as well as false now. Parse success. Now, if you give it a word that it doesn't understand, like hello, it's gonna barf at you, and it'll kind of tell you what it's thinking at the point that it got confused during the parse. So it says there's a syntax error and unexpected H. Basically, it got confused when it saw this first letter H, because instead of an H, the parser was expecting to see one of the following: a T based on this rule that is trying to match the word true. So Nearley also generated this rule that was based on this string of characters, TRUE, and again, you can see from this generated grammar here that in order to match, whenever you write a string literal that has multiple characters in it, Nearly actually generates a rule that matches multiple character literals, one after another, and you can see that in this output here. It's expecting either a true to match the word true, the word false, or a character matching this character class, a character between 0 and 9. So it's cool to understand the internals of Nearly. So that's one way you can get insight into it, by looking at the error messages. So we got boolean working now. Let's get nulls to work. So as you remember, JSON, the JSON format supports, numbers, strings, booleans, nulls, arrays, and objects. So a null is just the string null. So let's test that out. Parse. So we gonna feed it the word null, but why doesn't it work? Let's see. Unexpected n. Instead, I was expecting to see one of the following: true, T for true, F for false. I don't see anything referencing this null string literal, and the reason why is this null is actually a special word in Nearly. So this guy doesn't work out, and trying to redefine it also doesn't work. The word null in the Nearly language actually means the absence of a match. So like this should match the empty string. So in order to fix it for our situation, we're gonna have to name this symbol something other than the word null. So maybe we'll say like underscore or dollar null. Let's go with dollar null. As I think Whitehead actually called it my null. Okay, I'll follow what he did here. So Whitehead says rename it to my null, and now null is able to be parsed. So watch out for that if you're using Nearly. You can't use the word null. Perhaps they should give a little better message indication, error message indication for that when you're trying to use it. Okay, now strings. Let's try to match strings. So string. How do you define a string? A string is a single, a double quote in some characters and then another double quote. And to match the characters, again, we'll use this recursion trick to match one or more character. So characters can either be one character or a character and then more characters. And then what's a character? A character, we're going to use the character class syntax to match a single character. So this is saying this is a character class here, and this caret here, that means not, or does not match. So it and this guy here, that is a double quote, and it this is a double quote, and in Nearly a double quote must be escaped with this slash. So basically this character class here, based on that, this character class matches any character that is not a double quote. Okay, so a character is any character that's not a double quote. There's going to be exceptions to this, notably with the escape characters. We'll deal with that later. That gets slightly complicated, and we'll skip that for now. But this is like a simple, basic way of representing strings. Well, there's an error message coming out of Nearly. It doesn't like this single quote for representing strings, I think. So we're gonna fix it by using double quotes, but escaping the double quote within them. And let's see if that works. Okay, so I'm gonna try to match the ABC, the string ABC, and that does work. Cool. So that's, there we have it. That is strings. What about arrays? Okay, so arrays, and we'll actually rename the input symbol to a value symbol, which to allow us to use the values within an array, because we can have match values within an array. So we'll say the input is a value, but an array can be array starts with the open bracket, closes with the close bracket, and then within an array there's array items, and an array items can be either one value, which recurses back to here. So because we can have an array of any of these things, array of numbers, array of booleans, or a mixture of the various things. Array that has a null in it, a string in it, even an array of arrays, right? So an array item can be a value, in which case it would just be an array with one value in it, or it can be a value, then a comma, followed by a comma, and then more array items. So let's generate the parser again, and now we'll try to match an array. And it works. Let's try an array with a number in it this time. That also works. Array with two numbers. That also works, but an empty array doesn't work with this. And if you look at the error to try to understand what's going on, it's saying, well, unexpected, it got confused when it saw the closing bracket. Because instead of that, is expecting either this double quote. Well, this is a gnarly representation of a double quote, but it is a double quote based on if it happens to be a string. Here you can kind of follow the train of thought of the parser here. The parser is saying, when I try to match an input, then what if the value is an array? Well, then the array is going to start with a open bracket, which it did fine, which is what allowed it to advance this read cursor here to after this open brackets, and then now it's trying to match array items. What's an array item? Array items is a single value, and a single value could be a string. So the parser is saying, if the value in the array was a string, then I'm looking for a double quote here. But there's another possibility. What if the value inside the array is another array? Then I'm looking for an open bracket. What if the value is a boolean and it's the true, is the true literal? Then I'm looking for a t. All these possibilities, n for null, and a character matching a digit if the item was a number, but none of it allows for an empty array, basically. So looking back at the grammar here, it's true that this grammar doesn't allow for empty arrays, because an array items has to be at least a single value, which has to be one of these things. There's nothing that allows it, the array items, to be nothing. So with that, for you, the viewer, if you want to try to figure out a solution for that, I like to pose this challenge to you. So if you like to take a few moments to figure out the solution for this, how can we make this grammar match an empty array? You can pause the video to take a bit of time to do that if you want. While you're doing that, I'll give you a couple seconds. Okay, so if you decided to do that, congratulations. Yeah, I hope you got the right answer. So if you said, I'm gonna review the answer right now. So if you said, just add the possibility of null. Remember we talked about null, how null is a special keyword in the Nearley grammar? Well, we could actually use null here. So if we said it's possible for this array items to be null, then that actually allows for the stuff inside between the brackets to be simply an empty string. Let's try that. Let's see what happened. There's an error. It still doesn't work. Did we forget to generate? Yeah, he probably forgot to generate. Okay, all right. He just forgot to generate the parser. So that works. We're able to parse an empty array now. However, there's a secondary problem with this approach, which is that now it allows for trailing commas. So let's see that. So yeah, a trailing comma is able to be matched. Why is the trailing comma able to be matched? Because after, so if you have this 1, 2, 3, actually let me do fewer, just 1, 2, and then a trailing comma. This trailing comma is gonna match with this one, and then the array items after that could be a null, so there could be this empty string after this trailing comma, which does get matched as array items. So how can we change this grammar to eliminate the possibility of matching a trailing comma? And basically we want to make the trailing comma invalid and only this valid. If you want, I'll let you take another moment to think about it. Again, I'll give you a couple of seconds. Okay, if you decided to do it, congratulations. You made good use of your brain cells. But if you just want to enjoy the show, the answer is remove null from the possibilities of matching an array items, and instead make the conditional on the array. Allow the array to be simply an open bracket and then followed by a closed bracket. So this is the grammar that will basically parse arrays correctly based on the JSON specification. So now with a trailing comma, the parser gives you an error. Let's read this error. So it's actually confused when it sees the closing bracket. When it sees the comma is still correct. After the comma is just expecting another value. So and it tells you that. It says, I'm not expecting the closing bracket of the array. Instead, I was expecting a double quote for a string. Maybe a string is coming next after the comma. Or if the next value in the array is a nested array, I could see an open bracket. Or if it were, it could be an empty array, nested empty array inside this array, based on this rule where the array is just an open bracket followed by a closing bracket. Or it could be a T based on a true literal, or it could be F based on the false, literal, and so on and so on and so on. So now, after we modify this grammar, trailing commas are no longer allowed, and that's pretty cool. But if you get rid of the trailing comma, then it should parse correctly. Let me see if that's true. Yeah, it parses correctly. So that's where I want to stop here. So far we covered how to parse numbers, booleans, nulls, strings, and arrays. We haven't done the entire JSON language. We may do that in the future, or just go more into how to use Nearly in general. I plan to, YKid and we plan to produce more content based on Nearly and making parsers. So I hope that you stay tuned. Thank you for watching.